Okay, so for this lecture, we'll be having part 2 of the Laplace transforms. But for this one, we'll start with the inverse Laplace and the Laplace transforms of the derivatives. In here, you can see the table that I have presented last time, the table of Laplace transforms. So I want you to know this by heart. Okay, and then the first shifting theorem. So when you have the form of e to the at times the function of t, how do you have that? So in here is the table of the Laplace transforms of those with e to the at. So basically applying the shifting theorem, because of that, you'll have an s minus a. For every letter s, it becomes an s minus a. And also last time, we have the derivatives of the transforms. So basically, if you have this form, the Laplace of t to the n, function of t, you will have to apply -1 raised to the n times the nth derivative of f of s. So we had this last time. And these are some, Laplace transforms as well. So for this lesson, we'll start with the inverse Laplace. So still the same symbol, the cursive L or the capital L, but then you'll write there to the -1. So the inverse Laplace of an f of s is now an f of t. Because you know that the Laplace of an f of t is an f of s, we'll just bring it back to the function of t. So some properties. So if you have two f of s functions here, so f of s and g of s, let's say that, the inverse Laplace of these can be separated. So you can choose to perform the inverse Laplace of f of s first, and then the inverse Laplace of g of s. Okay, so let's try. Let's say this one. Let's try to recall first what we have for our Laplace. Let's just say we have an f of t and an f of s. For the constant, what is the f of s, guys? For the constant, if you can recall, k over s. For t raised to n, what will it be? Isn't it n factorial all over s to the n plus 1, right? What about e to the at? 1 all over
S
s
minus
minus a. What about for sine? K over. What about for cosine of kt? So these are some guides. Now, you are given the function of s. I would want to get the function of t. Can you give that to me? So the inverse Laplace of the functions of s should be a function of t. So what are these? So 7 over s. Can you give me that? Very good. It's simply 7. Minus, we don't need the 8 yet. So let's move the 8 outside. Take note that you have an s cube at the bottom. Looking at the table on the right, most likely, what is your letter n, guys? 2. So I can say that this one, okay, so this one first. I can say 8. This one is s to the 2 plus 1. Am I correct? But if this is 2, there has to be a 2 factorial on top. So if I supplied a 2 factorial there, I should also supply a 2 factorial outside. So here, it's 8 over 2. And then what's the form? 2 factorial all over s squared plus 1. What will this be? Isn't this t squared? So in here, you understand what I did, right? that the s cubed is actually an s squared plus 1. And then referring to the table on the right, if there's an n plus 1, there should be an n factorial on top. So that means that is a 2 factorial. Since I was the one who supplied the 2 factorial on top, I should also supply a 2 factorial at the bottom to cancel out the effect.
So
Because I have to refer to the one on the right. Sige. I'll erase first so you understand. Okay. You know that what you know here is that the inverse Laplace of an f of s, at the end I should get an f of t. All right. So the final answer should be in terms of letter t. This one, let's just call this letter A, letter B, C, D, and E. For letter A, I hope there's no problem. 7 over S, that's just the constant over S, so that means it's just a constant. Are we together here? Okay. Letter B, 8 over S to the third power. There is a problem. There's an S at the bottom. So maybe that's an S squared plus 1. And then the 8, let's bring it out, just like in our integration. But then take note, if there's a 2, there has to be a 2 factorial on top. I supply a 2 factorial at the bottom. All right. So that means this one is 4 times the inverse Laplace of 2 factorial s to the 2 plus 1. Therefore, this is actually 4t squared. All right. So let's go to letter C. 3 over s plus 4. We don't need the 3. Let's bring it out. So the inverse Laplace of 1 over s plus 4. Let's look at the table on the right. What does it look like? Isn't it the third number? The third line? So what will it be? E raised to negative 4t, right? And then letter D, 3 over 4s squared plus 9. I never taught you something like this. The s squared does not have a number when you refer to the table on the right. So what I would do is this. If I factor out the 4, will this not be 9/4? Am I correct there? Okay. Now, in here, can you tell me what is the K? Look at that. What is the K? 3 over 2. That's correct. The problem is, when you're referring to sine, you know that I'm going to use sine. Why is it sine and why not cosine? Because on top, it's a constant. Can you follow? So that means I have to have a 3 halves on top. What do I need on top in order to have a 3 halves? Very good. I need a 1/2. But since I am the one supplying the 1/2, I need to supply a 2. So that means I need a 2. And there's a 4 at the bottom. Here, that becomes a 3 halves all over s squared plus 9/4. So this one, I can basically say that's just 1/2 times the inverse Laplace of 3 halves over s squared plus 9/4. Can you give me the answer for this one? Very good. So s over s squared plus 2. Oh, is this sine or cosine? Just by looking at it. Cosine. What is the value of your K? Root 2. That's correct. Therefore, the inverse Laplace of this one is basically what?
cos square root of 2t.
Very good. So that means the final answer is 7 minus 4t squared plus 3e to the negative 4t plus 1/2 sine of 3/2 t plus cosine square root of 2t. Okay. So basically, you refer to this, but then you are getting the inverse of it. That's why it's a bit more tricky, but I like it because, you really have to think and use your mathematical and logic skills. So in here, find the inverse Laplace transform of f of s. So basically, you're getting the f of t. You're given this one. However, you have to remember that when you're given something like this, I do not have that in this table. In this table, it's purely s squared or something that contains this and then squared. It does not contain an s. That's separate. So what do I do? It's called what? Remember partial fractions? So that one can be factored out. The denominator can be factored out as s plus 3 and s plus 2. I hope you still remember how to get the partial fractions. For example, you have in here 3s over s plus 3 and s plus 2. So by partial fractions, you can say a over s plus 3 plus b over s plus 2. So multiplying everything by the LCD, you'll end up with 3s is equal to a, s plus 2, this is b, s plus 3. So since it's basically linear factors, you can just get the roots. If s is equal to negative 2, so this is negative 6, a times 0 plus b, because negative 2 plus 3, so that cancels out. You already have a value of b, which is negative 6. And then if s is equal to negative 3, you'll get their negative 9. A, negative 3 plus 2 is negative 1. And then b times 0. That cancels out. A is equal to 9. So you'll end up having 9 over s plus 3 minus 6 over s plus 2. All right. So what is the inverse Laplace of 9 over s plus 3 minus 6 over s plus 2? Can you give me the answer? Like this, right? 9e to the negative 3t minus 6. What's the answer? That's that. That's it. That's correct. This is the function of t. That's the inverse Laplace. Very good. So in here, for example, you're given something like this, and then you can separate this into 2. The problem is that this one is linear. This one is not linear, right? What will be the answer in here, guys? Can you please give me the answer? What's the inverse Laplace?
Sir, e raised to negative 8 3t.
2 cosine of 1.
1t, right? So this one, there's no problem. And then, do you remember if I ask you, what are the roots of this one? If I just ask you, what are the roots? S is?
Positive, negative, I.
Okay. Can you give me the inverse Laplace of this? All right. So the first one is 3. So I don't need the 3. Okay. Here, Can I say that this is s to the 2 plus 1?
Yes, sir.
What should be on top?
Factorial, sir.
So what should be outside?
Q.
All right. So here, there's no problem. That's easy. This is easy. So this one becomes
3 over
3 halves of what? T
over
raised to the second power, right?
yes.
Minus, what's here?
Sir, 3e raised to negative t.
Very good. Now look at this one. I never taught you something like this. In the table, you don't have something like this. But what you can recall is this. Remember that f of t and f of s. If, for example, I say 2t, can you give me the f of s? What's the answer? 2 over? Is it s? Isn't it s squared? Note that t to the n is n factorial all over s raised to n plus 1. Isn't it that the power of t is 1? Therefore, at the bottom, it should be s squared. Am I correct? So that means for the third term, I don't need the 2 yet. That one is similar to this, similar to the one I gave you. That is basically 2t. However, there's an s plus 1. That's actually the first shifting theorem. This one. Diba? In the form of e to the at f of t. Remember? If you can recall this table, there, e to the at becomes that. T to the n, e to the at is this. That's actually this one that I gave you. Okay, so look at this. If you have, for example, the Laplace of a function of t, and then the Laplace given is this one in terms of s. What is the Laplace of e to the 3t and then that one, that function of t? And because of that e to the 3t, you just apply the shifting theorem. Instead of simply s, let's make it s minus 3 squared. So in here, you apply the first shifting theorem. Okay, let's go to the next. Again, this one, no? Where we apply the first shifting theorem. So here, you can say that the roots of the denominator will be complex. How do we know that? Because this one is not factorable. If you try to get the roots using the quadratic formula or the completing the square method, you'll be able to get complex roots. Okay, so let's try doing completing the square. Of course, completing the square, this will give you s squared 6s plus 9. Since it's plus 13, it becomes plus 13 minus 9. So we just write plus 4. So combining the first few terms, combining the first 3 terms in here, that becomes s plus 3 quantity squared. And then the 4 is simply s squared. So for this, you have to take note that we still can't get the answer for this because in the table that I gave you, if it's k, it's okay to be alone. But if it's s minus a at the bottom, it has to be an s minus a on top. Since what I gave you in here is an s minus k, so that's an s plus 3, on top, it should also be an s plus 3. So what do? We supply a plus 3, just like here, but then you have to subtract also to remove the effect. So you add and then subtract. So on top and at the bottom, it's similar. It's s plus 3. So basically, you apply the shifting theorem here. It's in the form of what? Cosine or sine? So let's write. If your f of t is equal to cosine of kt, it's s over s squared plus k squared. If your f of t is sine of kt, it's k over s squared plus k squared. So we have something like that in here, only that instead of just s, it's an s minus a or s minus whatever letter you want. So what will this be, guys? It's a cosine, right? Cosine of what? Cosine of 2t. Do we have shifting?
Yes, sir.
By how much?
3.
What's the sign? Negative. Very good. Therefore, the answer is cosine 2t times the shifting, e to the negative 3t. In here, there's a 3. Because at the bottom, it's 2 squared. I should supply a 2. I should supply a 2 here. But I need to remove the 2 as well. So let's supply a 2. But then I have to have 1/2 outside. That's why 3 over 2 is found in front. And then this one is basically sine of 2t. However, due to the s plus 3, there's the first shifting theorem. So let's try. Find the inverse Laplace transforms of f of s. So basically, I'm asking you to get the f of t. Sige nga, let's do this, guys. So for this one, it's easy. So this one is 2 minus, you can say 5 over 2 t squared, no problem with that, minus 3 e raised to negative t, no problem with that. And then in here, you can say, that's simply 2. And then think of this, the whole thing, as an s squared. If that's an s squared, it's simply 2t. But because it's not just an s squared, it's an s plus 1, there is the shifting. All right, let's go to the next. Para you'll understand more. Let's do separately. Term A, term B, term C. So for term A, 7 over s plus 2 cubed. So think of this as 7 over s cubed, guys. This is the f of s, sorry, there. This is the f of t. What is the transform of 7 over s cubed, guys? 7 over 2 t squared. Now, because it's not just an s cube, it's an s plus 2 cube. Can you give me the transform based on this? This becomes?
E raised to negative 2t.
So, very good. 7 over 2 t squared e to the negative 2t. So this is the answer for A. Let's go to B. 3s over s squared plus 1. This one's quite easy. What is the transform? 3 cosine of t. Did you get the same? For letter C, it's quite tedious because it's s squared minus 2s plus 10. So instead of s squared minus 2s plus 10, can I make it like this? What is the number that I need to complete the square, guys? 1. And then I need to subtract 1. So that means this is 2 over s minus 1 squared plus 9. Now I have a question. Your s is now an s minus 1. Your k, what is a k, guys? 3. So that means the one on top, I don't need that. I can bring it out. I need a 3, s minus 1 squared plus 9. But since I supplied a 3, I need to bring out 1/3. So this one is 2/3 times 3, s minus 1 squared plus 9. So now let's transform this. What is the transform of that? You know that the form is sine or cosine? Sine. So 2/3 sine of what? 3t. Question, is there a shifting or none?
Meron po.
Shifting by how much? So by 1. Am I correct? So that's the answer. Therefore, the final answer for this is 7/2 t e to the negative 2t plus 3 cosine t plus 2/3 sine of 3t e to the t. Next, this one, look at the one at the bottom. For the one at the bottom, it's an s minus 3 raised to the 4. So obviously, some of you might think, sir, we need to expand that. No, because if we expand the s minus 3 raised to the 4, it's going to be even more difficult. But if I say that this one, if I take this as, let's just say, 4 over s minus 3 to the 4 plus 2s over s minus 3 to the 4, and then analyze each individually, maybe we can get an answer. Okay, look at this. The first term, just think of it as an s to the 4. Is there shifting in there? Yes, there's shifting. Kasi bakit? S minus 3 siya. Sana kung s to the 4 lang siya. We can deal with that later. Let's think of this one, the second one. The 2s over s minus 3 raised to the 4. As I said, if there is shifting, whatever the number there is should be the same as the one on top. Therefore, if I would make it like this, two times s is 2s. That's correct. 2 times negative 3 is minus 6. I am the one who supplied it. Therefore, I need to remove the effect. Why I did this one, is so that I would have an s minus 3. So I'm forcing it to have an s minus 3. So it's going to be 4 s minus 3 raised to 4 plus 2 s minus 3 over s minus 3 to the 4 plus 6 over s minus 3 to the 4. So just by looking, maybe we can combine some of the terms. So in here, it's going to be 10 over s minus 3 to the 4 plus this one is simply 2 over s minus 3 cubed. Let's just recall. P raised to n, what's a transform?
N factorial over t raised to s raised to n plus 1.
Right? So this is the f of t, that's the f of s. So there was a question, how did we get the plus 6? Take note, I forced this one, this term, I forced it to have an s minus 3. But when I made it an s minus 3, there's a multiplier 2 outside. 2 times negative 3 is minus 6. So to counteract what I did, I have to add a 6. So this one, the first term, the n is 3. So am I correct in saying that there should be a 3 factorial? 1 over 3 factorial outside? So that means in here, 10 over 6, because 3 factorial is 6. And then what's the answer in here? That's t to the third power. Is there a shifting? Yes, by 3 units. Now let's go to the second one. What is the n in here? 2, di ba? So n factorial over n plus 1. So I don't need to supply a 2 anymore. I have a 2 there. So what will this be, guys? Very good. T raised to 2 is there shifting?
T raised
E
to
to the 3t. Therefore, if I simplify this, divide this by 2, 5/3, and then t cubed e to the 3t plus t squared e to the 3t. This is the inverse Laplace. Now this one, guys, again, maybe we can separate. So the inverse Laplace of 2s over s squared plus 9 minus 18 all over s squared plus 9. Okay. You don't need the 2 there. You can bring it out. What's this? What's the inverse Laplace of that one?
cosine of 3t.
Cosine of 3t. Very good. In here, there's a thing. What is the k for number 2? The k is 3. So I should have a 3 on top. There's an 18. What do I not need on top?
6
That's a 6 times 3. So maybe this one is simply 6. And then
sine 3t.
that's the final answer. 2 cosine 3t minus 6 sine 3t. That's correct. Next, please. So there are 3 terms again. If there are 3 terms, maybe what you need to do is complete the square. So s squared minus 4s plus 4. And then there's an 8. So we subtract a 4 because we added a 4 here, right? Okay. So inverse Laplace of 1 all over s minus 2 quantity squared plus 4. Okay, just by looking at this one, guys, what is the form? Sine, very good. So what is your k? 2. So that means if for sine, if the k is 2, I need a k on top. So I need to multiply a 2. But since I multiplied a 2, I need to bring out, so 1 over 2. Okay. So that means the inverse Laplace of that is 1/2. And then you said earlier it's sine. Therefore, what will it be?
Sine
Sine of 2t. Is there shifting?
yes, sir.
By how much? It's 2t. Take note, guys. Be careful with this. Look at this. For shifting, look at the table. It's s minus a. And then that's e to the at. If it's s plus a, that becomes a negative. Okay? Be careful with those. So that's the answer in here. It's easy. Next, please. So s plus 2. S minus 2. And then s minus 4. So let's just say a all over s minus 2 plus b all over s minus 4. So multiply everything by the LCD. You'd get s plus 2 on the left, a, s minus 4 plus b, s minus 2. So if your s is equal to one of the roots, let's just say 2, so that becomes 4. A times negative 2 plus B times 0. That cancels out. Your A is actually negative 2. If your S is equal to 4, this is 6. A times 0 plus B times 2. That cancels out. B is actually equal to 3. Therefore, this one could be separated as negative 2 over S minus 2 plus 3 over S minus 4. So you're actually solving for the inverse Laplace of that one. Can you please give me the answer?
Negative 2 e raised to 2t
Very good.
plus 3 raised to e raised to 4t.
Very good.